Vanakkam. You all are spending your valuable time in a useful way by seeing this video presented for you by Vidhyalakshmi Senior Secondary School, Vellore. This is a foundation program in mathematics and this is for grade 8 and above. This is a series of video in which we already have been completed version 1.0 and now we are going to start a fresh track in version 2.0. And this is our first video module in this version 2.0 in which we are going to learn some advanced problems in the case of the chapter Indices. Okay, now let us start our lesson with our first question, and already in version 1.0 you all are used to in listening 5 numerical problems which we have solved in each and every video. By the same way, in the same track, in this track also, in version 2.0 also, we are going to solve 5 numerical problems in this session of video also. Okay, let us start our session with our first question. Yes, this is the first question given here. The value of the expression is asked here. An expression, a lengthy expression is given here. You can see over the board. See, a lengthy expression is given. We have to simplify this by applying the law of exponent and we have to find the exact match of the choice. Okay. To find the answer, I wanted to take this question carefully without making any mistake because this is such a long expression that I need to take it carefully. Okay. First I take down the question. See, 4 power n multiplied by 20 power m minus 1 multiplied by 2 power minus m minus n multiplied by 15 power m plus n minus 2. Okay, the numerator part is over. Now I wanted to take the denominator part. 10 power m multiplied by 5 power m plus n multiplied by 3 power m minus 1, and at last we are having multiplied by 6 power n minus 1. Yes, I hope that I have taken the question carefully without doing any mistake. Now I want to solve this expression. Okay, to solve this expression, what I want to do, when I look at this whole thing, I can see that here we are having 4 power n and later on we are having 20 power m minus 1. So in the exponent part, when you look at the exponent when you look closerly the exponent part, you can see that we are having the exponent in terms of n and also in terms of m. Here also m we are having, n we are having. So you can see here also m, n. So all the exponents are in terms of m and n. Okay, that's good. And when I look at the bases, that is the base 4. Here we are having the base 4. Here we are having the base 20. Here we are having base 2 and here we are having base 15 in the numerator. Okay. When I look at the bases in the denominator, we are having 10, 5, 3 and 6 in the denominator. Okay. Right. So how I am going to solve this expression? See, first I wanted to write this 4 as 2 square. So 2 square the whole power n. Okay, I want to reduce each and every number to the smallest one, to the smallest prime number at most. Okay, so this 4 I am expressing as 2 square. So 2 square is 4, you know that. So 2 square the whole power n multiplied by this 20 I can write like 4 multiplied by 20. Am I right? 4 multiplied by 20. This 20 I can write like 2 multiplied by 2 multiplied by 5, because 5 4s are 20, so altogether you will be getting 20. So the whole power m minus 1. Okay, then afterwards this 2 power minus m minus n, I can't do anything with that. And at last we are having this 15, no, this 15 we can express like 3 multiplied by 5 the whole power m plus n minus 2. Yes, the numerator part is over. I have been factorized all the bases. Okay, then going to the denominator part, this 10 I can factorize like what? Yes, 5 into 2. 5 multiplied by 2 the whole power m. Okay, then here we are having 5 power m plus n followed by 3 power m minus 1 and followed by this 6 we can in turn we may express like 3 multiplied by 2 the whole power n minus 1 we are having. Yes, the first step of the process is over. Then in the next step what I am going to do, see, in the next step I am going to apply the rule of exponent here. Okay, I am going to apply the rule of exponent. So when you look at the bases, we are having different bases in the numerator, but we are having the same base at different places. You can see that we are having 2 here. By the same way here also we are having 2, but 2 times, and also here we are having 2. Yeah, that's all. So let us take the exponents which are having the base 2. Let us collect all the exponents which are having the base 2 at first separately. Okay. So what you will have when you separate those exponents separately, see this 2. Okay, I am going to take it separately. And and also I am going to apply the rule of exponent here, that is the power rule of exponent. You all know that 2 into n it will become 2n, am I right? So 2 power 2n it will become, and afterwards we are having here 2, and this 2 is actually having the exponent m minus 1. So I am adding that m minus 1 here, m minus 1 over this 2. Why I am adding? Because I am applying the product rule of exponent. A power m multiplied by a power n gives a power m plus n. So that's why I am adding. So by the same way this 2 is also having this m minus 1 as exponent. So I need to add that m minus 1 also, and later on this last one, that is 2 power minus m minus n. So minus m minus n added here. Okay. Yes. So taken this separately. And after taking this, what we have to do? We have to look at the next exponent having the base 5. Okay. So we are having the base 5 exponent at different places. You can see that here we are having base 5 exponent, and here also we are having base 5 exponent. Okay. So clearly I need to take it separately, multiplied by 5 to the power of, this is having m minus 1, the exponent. Okay, then after here this 5 to the power of m plus n minus 2. So m plus n minus 2. Okay, added the powers because taking the common base and we are adding the powers. Okay, so this is one set of exponent. And what is the another one more thing we are having is 3. Yes, 3 is the only thing that we are having here separately, and that 3 actually having the exponent m plus n minus 2. So I need to take this, I need to take this 3 whole to the power of m plus n minus 2. Okay, m plus n minus 2, but all these are in product, so that I need to put the multiplication symbol. By the same way in denominator also I need to separate the terms having different bases. I need to combine the terms having different bases. Okay, see, first of all I want to look at the exponents which are having base 2. Okay, we can see that this exponent is having base 2, and also here we are having one exponent having base 2. Okay, so when I join those two, what I will be getting, you can see that 2 to the power of m we are having, followed by Here 2 to the power of n minus 1. So plus n minus 1. Okay, that's all. No any other we are having here. So then after this, what we have to do? We have to go for the next one. The next one, I need to search for the one which is having base 5. So you can see that this is having base 5 and also this one is with base 5. So this is actually 5 raised to m. So what you will have? Multiplied by 5 power m, and here we are having 5 power m plus n. So plus m plus n, okay, plus m plus n. So that's all about that. That exponent is over, that part is over. Then I want to go with the exponent having the base 3. Base 3 exponent, base 3, yes, here we are having 3 to the power of m minus 1. And here also we are having the exponent with base 3. So 3 to the power of n minus 1. So that we have to add plus n minus 1. Okay, plus n minus 1. Yes, I have been separated, that is collected all the exponents with the common base. Now in the next step, I want to simplify this. When I simplify this, what I am getting, you can see that see something, some of the terms may be cancelled here. You can see that this is minus m and this is plus m, which may get cancellation. By the same way, is there any more cancellation is possible here? I want to see that here 2n and this will be subtracted, actually it will not get cancelled. Okay, no any cancellation is possible furthermore. And then when I come here, is there any cancellation possible? I want to see that. See, no cancellation is possible here, and here also no possible cancellation, and in the denominator also no possible cancellation. Then I want to simplify. I go for simplification. Okay. So when I simplify this, what I will be getting, you will be having 2 to the power of, this is actually m, only this is the m we are having here. So 2 to the power of m followed by 2n we are having here, 2n, here 2n and here minus n. So 2n minus n is n plus n. Okay, 2n minus n is n plus n. Then this minus 1 and this minus 1, when you add together, you will be getting minus 2. So this is the simplified expression for in the case of numerator. Okay. Yes, now after cancellation we are going to simplification. So you can see that here we are having m. So over 2 power m we are having 2 power m, and then here 2n, you can see that here we are having minus n. So when 2n minus n, if you simplify that, you will be getting plus n. Okay, plus n, and then this minus 1 and minus 1, this minus 1 and this minus 1, when you add it together, it will become minus 2. Okay, so this is the first term, and followed by we are having 5 over that. So when you add this m and this m, you will be having 2m. And after that you will be having this n plus n, and then this minus 1 and minus 2, when you add together, what you will get? You will get minus 3. Yes, minus 3 you will be having, multiplied by, at last we are having 3 to the power of m plus n minus 2. Yes, the denominator part is over in this simplification process, and followed by we have to simplify the numerator part is over in the simplification process. Now we have to simplify the denominator part. You can see that 2 to the power of, this I need to take it same, that is m plus n minus 1, I need to take it same, followed by what we are having, 5 to the power of m plus m is 2m plus n we are having, yes, 2m plus n, and over this 3 we are having m plus n minus 1, this minus 1, when you add together you will get minus 2. Okay, so these are the 3 terms which are in product in the denominator. Okay, now when I look at the numerator and denominator, I can see one thing. Yes, because here also 3 power m plus n minus 2, and here also 3 power m plus n minus 2, which it can be cancelled. Okay, then I need to simplify only these two part. Okay, so how I am going to simplify? We just look at the board carefully. So these two are having the same bases, so I need to keep the base common, and I need to apply the quotient rule of exponent here. When I apply the quotient rule for exponent here, what this will become? M plus n minus 2, I need to subtract the exponent of the denominator. So minus m minus n minus 1 will become plus 1. Do you understand? This m becomes minus n, this n becomes minus n, and this minus 1 becomes plus 1 when we apply the quotient rule for exponent. Okay, then followed by 5 to the power of, we are having 2m plus n minus 3 in the numerator, and this has to be now taken to the numerator, that is, this has to be subtracted from the exponent of the numerator. So like minus 2m minus n. Okay, this plus 2m becomes minus 2m, and this plus n becomes minus n. That's all, and this has been cancelled. So only these two terms are the available terms. Now no any space I am having here, so I need to erase this space. So I will be erasing this. Yes, now we have to simplify this furthermore. We have some more steps. Yes, now we have to simplify this further. We need to go some more steps for to get the answer. See, 2 to the power of, what we are, some cancellation is possible here. Yes, I can make cancellation here. This plus m and this minus m, also this plus n and minus n. Yes, we can cut off those things. Okay, after making those cancellations, what we are having here, here also plus 2m and minus 2m, this plus n and minus n, yes, it will go off. What is the remaining part we are having here after cancellation? Here minus 2 and here plus 1. So what is that? 1 minus 2, you will be having minus 1. Yes, correct, minus 1. Okay. Yes, after cancellation, what we are having the remaining part? Here we are having a minus 2 and here we are having plus 1. So 1 minus 2 you will be having 2 to the power of minus 1 you will be having. Followed by over this exponent 5, what we are having, over this base 5, what we are having, see, minus 3 only we are having. We are having this minus 3 alone. Yes, minus 3 alone we are having. Yes, very good. But you all know that this 2 power minus 1 can be written in the form of 1 by 2, and this 5 power minus 3 can be written in the form of 1 by 5 cube because of the application of rule of negative exponent. So followed by 1 by this 2 we have to take, and this 5 we have to multiply 3 times, 5 multiplied by 5 multiplied by 5. So you will be having 5 2s are 10, and this is actually 5 is a 25, 25 into 10 you will be having what? Yes, 250 you will be having. So it is 1 by 250 is the answer for this question, and the solution is actually matching with our answer in option A. This is such a long problem, lengthy problem. We have to apply the rules carefully and we have to follow the steps carefully. Then only you can able to get the correct answer. Okay. Yes. Now we are going to the next question, question number 2. Yes, in this second question also we are having an expression which is given in the form of quotient, but we are having exponents even in denominator and also in numerator. Okay. See, so I am going to take the question. So 0.6 the whole power 0 minus 0.1 the whole power minus 1 the whole divided by 3 by 2 cube the whole raised to minus 1 and 3 by 2 the whole power 3 plus minus 1 by 3 the whole raised to minus 1. Okay. In this question, now when I look at this 0.6 power 0, what I am getting? Yeah, it is equal to 1 because of the 0 exponent rule. So 1 minus the 0.1 in the form of fraction we can write like 1 by 10. So 1 by 10 the whole power minus 1 you will be having. Okay. The whole divided by, here this is actually 3 by 2 cube and it is having a negative exponent. Because of this negative exponent we have to make it reciprocal. So you will be having 2 cube by 3 multiplied by this 3 by 2 the whole cube. This 3 by 2 whole cube we can write like 3 cube by 2 cube. Why I am actually separating this exponent between this numerator and denominator? Because I can make cancellation here. So that's why I am separating here. Followed by we are having plus this minus 1 by 3 power minus 1. We have to take the reciprocal. So, we will be having what? 3 by 1, and this minus we have to take. This minus we have to take. We have to carry. Then after this step, we have to go for simplification furthermore, which is equal to 1 minus this 1 by 10 the whole power minus 1. Yes, again it is going to get the reciprocal, that is 10 by 1, nothing but 10. Okay, the whole divided by. Here I am going to do cancellation as such. I said this cancellation is possible, and yes, here also this 3 we are having 3 times, here had in the denominator we are having 1 time. So, when we make cancellation, you will be having 2 time remaining. So, 3 power 2 will be the remaining part here. So, I need to take 3 power 2, and here plus into minus minus, you will be having this 3. Get it? After this 1 minus 10 minus 9, 3 square 9 minus 3. So, which is equal to minus 9 by 6 is the result that we are getting, but here also we can make cancellation as because of the 3 is the common factor between the numerator and denominator. After cancellation, what is the final simplified answer we are getting is minus 3 by 2. So, this minus 3 by 2 is the answer for this question, and it is actually matching with our option C. Option C is the answer. Okay. Yes. Now, we have to move to the next question, that is question number 3. In this question number 3, you can see that we are having a quotient, that is we are having a equation. See, this whole thing is being equated with this 1 by 27, okay, and then it is asked to find m minus n. We have to find the value of m minus n. Options are given here. Yes, we have to do this problem. Now, let us take the question carefully. 9 power n multiplied by 3 power 2 multiplied by 3 power m by 2 the whole raised to minus 2, okay, multiplied by 27 the whole power minus n, the whole divided by 3 power minus 2m multiplied by 3 cube. Yes, let me take the question carefully now. 9 power n multiplied by 3 power 2 multiplied by 3 power m by 2 the whole raised to minus 2 into 27 to the power of minus n we are having the whole divided by 3 power minus 2m multiplied by 3 cube. Okay, that's all about the left hand side, and in right hand side this whole thing is equated with 1 by 27. Okay. When I look at this question, I can able to have an idea. This 9, that is I'm actually focusing over the base. There is this 9, 3, 3, 27, and here 3 and here 3. All these are multiples of 3. And in right hand side also it is given that 1 by 27. It can be also expressed as multiple of 3. So that what I wanted to do, I want to convert all the terms, all the exponents present in this equation to be with the same base 3. So that would be easy for me to calculate in the next step process. Okay. So for that I am going to convert everything to be with the base 3. So this 9 I can write like this 9 I can write like 3 square the whole power n multiplied by, here already we are having 3 square multiplied by here this is actually already we are this is actually with base 3. So 3 power m by 2 the whole power minus 2 multiplied by this 27 we can write like 3 cube the whole power minus n, okay, the whole divided by 3 power minus 2m multiplied by 3 power 3, and here this 1 by 27 I am going to write like 1 by 3 cube. Okay, then Here we can apply the rule of power of exponent rule. So when I apply that, what you will get? 3 to the power of 2 into n is 2n multiplied by 3 to the power of 2. I just keep it multiplied by, when I apply the power of exponent rule, this m by 2 and this 2 will be multiplied. When it is being multiplied, this 2 will be cancelled and you will be having minus m over this 3. Okay. So 3 to the power of minus m I will be having here, and followed by here 3 to the power of minus 3n when I multiply this 2, the whole divided by 3 to the power of minus 2m, 3 to the power of 3, I just keep the denominator same without changing anything. And in the right side we are having 1 by 3 cube, that in turn we may express like 3 to the power of minus 3 when I take to the numerator. Okay. Right. Then next I need to apply the product rule of exponents and the quotient rule of exponent at the same time in a single step. Okay. I am going to apply that. See, so all are having the base 3, no. So I am actually taking the common base 3. I want to add all the exponents in the numerator because all those are in product. So I want to add. So 2n plus 2 minus m, we are having already minus 3n. Okay, added all the numerator powers, and I need to subtract the denominator powers because it is actually the quotient rule of exponent. So this minus 2m will become plus 2m, and this 3 will become minus 3. So after doing all this, I need to equate this along with this 3 power minus 3. Okay, now I need to see for any cancellation or simplification. Is it possible here? I want to see that. Yes, some cancellation work is possible, not possible. Yes, definitely no cancellation work is possible here. So I wanted to do the simplification. So I am taking the left side part, that is 3 to the power of here 2n, and no, I want to look at m first. Okay, I want to look at the value of m. Here 2m we are having and here minus m we are having. So when you subtract this 2m minus m, you will be getting m. Yes, m. And then I want to see the part n. So 2n we are having here, and here minus 3n we are having. When you subtract this 2, what you will get? 2n minus 3n is minus n, you will be having minus n. Yes, then finally we are having this numbers, constants we are having. So when you look at those constants, that is, this is plus 2 we are getting here, and this is minus 3 we are getting here. So plus 2 minus 3, plus 2 minus 3, you will be having what? Minus 1. Yes, all the terms in the numerator have been simplified. Then I need to equate this along with this 3 power minus 3. So this biggest equation actually simplified in this smallest one, like this. Okay. Now what I can do easily, I can able to equate the powers because the bases are equal. When the bases are equal, we can equate the powers. We can equate the exponent. So when I equate the exponent, what is the result that I am getting? M minus n minus 1 is equal to minus 3. That is what I am getting. So m minus n is equal to this minus 3. When I take this minus to right side, it will become plus 1. Minus 1 to right side, it will become plus 1. So m minus n is equal to minus 3 plus 1 is 2 minus 2, but it is minus 2. So the answer for this question must be minus 2. So you can see that yes, it is there in the option C. Option C is having the solution minus 2. Okay. Yes. This is also a problem that we have to do in a careful way. Otherwise, you can, if you make any mistake in between, then definitely the answer will not come. Do it in a careful way. Then we are going to the next question. Yes, the fourth question of this session, and this is actually a smallest expression. We are happy to see this because this expression is very small comparing with the previous one and the previous one. Okay. In this, I want to take the question. We are having 25 multiplied by 8 power 1 by 3 plus 81 to the power of 1 by 4. The whole square, whole raised to 3 by 4. Yes. I want to start from here, because I want to evaluate the innermost bracket, expression in the innermost bracket. This 25 I keep it safe, this 8 I am going to write like 2 cube, the whole raised to 1 by 3, plus this 81 I am going to write like 3 cube, because 3 cube is 81, you all know. The whole, this 81 I can write like 3 power 4, because 3 power 4 is 81. When you multiply 3 4 times, you will be getting 81. The power 1 by 4 we are having already, and this whole thing is raised to power 2, and the whole power 3 by 4 we are having. Clear? After this step, see, when I apply the rule of the power of exponent rule, this 3 and 1 by 3, when you multiply, what will happen? We can make cancellation between these two. So after that, what is the remaining part here? Here we are having 2, because that is 2 power 1 is nothing but 2. Here we are having 3 power 1, that is 3. So 2 plus 3 we are having what? 5. Am I right? 5 we are having all together. Okay. So 25. So 25 multiplied by what I said? 5. But this 5 is raised to 2. And the whole thing is raised to 3 by 4. Understand? Okay. Then 5 square we are having. 5 square we are having. Here 25 we are having. Okay. So how many 5s are there in 25? 2 5s. And here we are having 5 square. It is nothing but 2 5s. So altogether we are having 5 4 times. So 5 can be raised to 4. Yes. And this whole, now it is under the exponent of 3 by 4. Again, now we have to apply the rule of, what rule? Yes, the power of exponent rule. When you apply the power of exponent rule, you will be getting 5 to the power of 4 multiplied by this exponent 3 by 4. And here after cancellation, you all know that 4 will be cancelled, and 5 cube is the answer for this question. But 5 cube is not there anywhere here. Oh, all these answers are actually given in scientific notation. So after converting the answer, after getting the answer, we have to go for scientific notation, convert it into scientific notation. Okay, 5 cube, you will be getting 125. So this 125, we have to convert it into scientific notation. So when actually decimal point we are having here, when that decimal point at last is moved 2 step, it has to be moved 2 step in order to get it after 1. So what will be the answer you will be having? So 1.25 multiplied by 10 power minus 2 or plus 2. We are actually moving towards left. When we move towards left, you will be having, yes, plus 2. So 1.25 into 10 power plus 2 is the answer. Okay, this is minus 5 plus 2. Yes, option B is only the answer, 1.25 into 10 power of plus 2. Let us move to the next question. The last question of the session, what will come in the place of star? It is given like star mark in this expression. This is an expression given here. See, I do not want to travel with this star because I just want to replace this star with x. So I want to keep it as x, and finally I will be telling you the answer. I will be selecting the answer. Okay, so I will be taking the question like 108 divided by x power 8 by 5, not star. For my convenience, I am taking like that. X power 7 by 5, here also 2 power 4. Okay. I want to find the value of x, so that here x is actually here at 2 places, so that I can make a cross multiplication here. When I make cross multiplication, this 108 will be multiplied with this 2 power 4, because this 2 power 4 will be multiplied here with 108, and by the same way this x power 8 by 5 will be multiplied with x power 7 by 5. Now after doing this step, I can see that these two exponents are having same base, so I can keep the common base x, and I want to add the numerators, that is the exponents. I need to add the exponents. When I add the exponents, 7 by 5 plus 8 by 5, you will be getting what? Yes, 15 by 5 you will be having, 15 by 5. 15 by 5. So 15 by 5 is nothing but actually it is 3. 3 5s are 15, so you will be having x cube. Oh, I left this actually left side expression. I want to simplify this also. So for that what I want to do, actually this is in the form of 2 power 4. This 108 I want to expand. For that I just take this 108 and I am going to have synthetic division. So when I am dividing by 2, you will be having 54, and after the 2 it will be giving 27, and later on you will be having 3 9 times, and again 3 3s are 9. So when I expand this 108, I can write it in the form like we are having 2 times here, but already 2 we are having 4 times here. So what is that? 2 we are having 6 times altogether, okay, and here we are having this 3 times. So 3 we are having 3 times. So here I can make the cancellation here, 5 1 time and 5 3 times. So what I am having here in the next step, you can see that we are having x power 3 is the remaining we are having. In left side we are having 3 cube multiplied by 2 power 6. Actually now I want to find the value of x. X is actually the part base, okay, and 3 is actually exponent part of this one, okay. So for to compare the bases, the powers must be equal, okay, the powers must be equal. I want to make the exponent in the left side and also on the right side to be same. Here x cube, see here we are having x cube, that is the exponent 3. Here we are having the exponent 3, but here we are having the exponent 6. So this exponent 6 has to be converted to be with 3 for to comparison, okay. Yes, that how I am going to do. See, it is very easy, I tell you. I am going to take this 3 cube, no problem with that, and this 2 power 6 I am going to just express like 2 power 2 the whole cube, because 3 2s are 6, I can separate like, okay. So which is equal to x power 3. Now you can see that this 3 cube multiplied by 2 square is 4 cube equal to x cube. Now you can see that altogether we are having the same exponent 3 on left side and also on right side. Yes. Then in the next step, what I am going to do, this 3 multiplied by 4 has to be combined, and this exponent has to be taken over 3 multiplied by 4 altogether, which is equal to x cube. Now I am going to compare both sides. So when I compare both sides, we are having the same exponent 3. So the value of x must be replaced with 3 multiplied by 4. So the value of x, what you are getting? That's all. Yes, with this question I am going to end up this session of class. I am going to end up this session of class, and I will be meeting you in the next video. If you like the video, if it is useful for you, please like it and also share with your friends, comment over the video. In each and every video you are having a course material, that is course notes is given at the end of the description and in the description area, and also an assignment is given there inside the link which is given in the description area. Please go through that, make use of that. God bless you all. Bye bye. God bless you.